Today we're going to talk about how to solve equations that have an angle other than a single angle right here. And this particular equation is about tangent, and tangent has a period of pi. Just want to remind you of that. Now when I see an angle here other than just plane x or plane theta, I'm going to make a substitution. And here I'm going to choose the letter y. You can choose any other letter that you would like. And I'm going to substitute in place of 2x y. So now my equation is going to look like this. The tangent of y is equal to the square root of 3. I want to know what angles I can replace with y that will produce this square root of 3. It's a positive square root of 3. And in particular, since I'm dealing with the tangent function, and the tangent function has a period of pi, I'm looking at what angles from 0 to pi produce this ratio. And basically that is a 60-degree angle, or if we're talking about radian measure, pi over 3 radians. Now I'm going to say pi over 3 radians plus any repetition of that, which is n pi. Because every time I add n pi to this, I'm going to get an angle that will produce this ratio. Now the next thing I'm going to do, stage 2 in this problem, is I'm going to go back and I'm going to say, okay, if y is equal to pi over 3 plus n pi, which is what I got over here, I'm now going to replace y with 2x. Replacing y with 2x, I get pi over 3 plus n pi. Now I want to get x alone on one side of my equation, and to do that I have two choices. I can either divide both sides by 2, or I can multiply both sides by 1/2. I'm going to choose to multiply both sides by 1/2, and when I multiply the right hand side by 1/2, I'm going to need to distribute that multiplication. Multiplying the left hand side by 1/2 gives me my x all by itself. Multiplying the right hand side by 1/2 and distributing that multiplication, I get pi over 6 plus n pi over 2. Now in the third step in this problem, I am going to replace n over here with varying numbers starting at n equals 0. When I replace n with 0, I get the answer x is equal to pi over 6. If I were to replace n with the number 1, I would get x is equal to pi over 6 plus 1 pi over 2. Getting a common denominator, x is equal to pi over 6 plus 3 pi over 6. That's the equivalent of pi over 2, which gives me the answer 4 pi over 6, which I can reduce to 2 pi over 3. Next, I'm going to replace n with the number 2. X is equal to pi over 6 plus 2 pi over 2. And x is equal to pi over 6 plus pi. Or x is equal to pi over 6 plus 6 pi over 6, which gives me the answer 7 pi over 6. Next, I'm going to replace n with the number 3. X is equal to pi over 6 plus 3 pi over 2. Again, getting a common denominator, x is equal to pi over 6 plus 9 pi over 6, which gives me 10 pi over 6, which can be reduced to 5 pi over 3. Next, I'm going to replace n with the number 4. X is equal to pi over 6 plus 4 pi over 2. Or x is equal to pi over 6 plus 2 pi. And I'm going to stop right there because clearly I'm going to get something that is over 2 pi. And I was asked at the beginning of this problem to produce the answers between 0 and 2 pi. So I think I'm done. And I think I've got one answer here when n is 0, one answer when n is 1, another answer when n is 2, a fourth answer when n is 3, and I have 4 solutions to this problem that fall between 0 and 2 pi. And now I'm done.